So in the previous class, we went through the basic concept of mensuration. So I'll just take a quick recap कर लेते हैं. Mensuration is one of the most important chapter of our entire syllabus. And the important thing about mensuration is not only its length, like कितना lengthy ये chapter है, सिर्फ यही important नहीं है, बल्कि इसमें से जो marking division बनती है for paper 1 and paper 2, वो भी काफी ज्यादा important है, क्योंकि आपका पेपर 1 तकरीबन 4 से 5 मार्क्स का मेंसुरेशन पर बेस्ड होता है, जबकि पेपर 2 would go up to around 10 to 12 marks for mensuration. Now talking about mensuration, तो यहाँ पर आपने पढ़ना होता है एक 2D शेप के बंडल को, like where you will be discussing all the 2-dimensional shapes जो कि आप बचपन से पढ़ते आ रहे हैं, and then moreover you would be going through the 3D shapes as well, which you would be like using in terms of their like volumes and surface areas. So over here we have the 2-dimensional shapes, including the circle, rectangle, triangle, square, arc, and then we have trapezium and other polygons as well. The polygons could be like the hexagon, the pentagon, decagon, and stuff like that. Now, for the 2D shapes, you would be required to ask or to find the area and the perimeter. तो आपको examiner जो हैं वो assess कर सकते हैं on 2-dimensional shapes to figure out the areas of them and also the perimeter. So we'll go through their formulas and their logics to have an idea of how to figure out the area and the perimeter of 2-dimensional shapes. Now, in against of it, if we look onto the 3-dimensional shapes, so the 3D shapes are actually the ones who are more practical in nature. They are like found more oftenly in our like day-to-day life, and the 3-dimensional shapes are the ones who could be touched and felt. तो आप ना सिर्फ इनको देख सकते हैं, बल्कि you could also touch them and feel them as well. Whereas if we talk about the 2-dimensional shapes, they could only be seen on paper and you could not touch them or feel them. So that is the major difference between 2D and 3D shapes. Now talking about the 3D shapes, we have a lot of them in our syllabus. Like we have cone, we have cylinder, cube, cuboid, then we have a sphere. Then if we cut off the sphere into two portion or two equal parts, we would be left with a hemisphere. And that hemisphere is actually an exact half of a sphere. So after that, we have the prism. Prism is just like a pyramid, but the difference between prism and pyramid is that a prism would have rectangular sides. The prism would have rectangular sides, while the pyramid, if you have seen the pyramid of Giza, have got triangular sides. Although their base would be a shape itself, like we have a squared base prism or a squared base pyramid, but their sides would be different. Like the sides of prism are rectangular, while the sides of pyramid are triangular. Now, moving on to the concepts of 3D, you will be like required to find the volume or the surface area of 3-dimensional shapes. So the examiner would actually be inquiring you to figure out the volume of these 3D shapes or the surface areas. Now for surface areas, we have got two distinct types. The first one of them is curved surface area. Like if I'm having a curved surface, so the curved region or that curved area would be used to find the curved surface area. While if I'm dealing with horizontal or vertical objects like a cube or a cuboid who have got plane surfaces, तो वहां पर हम deal करते हैं with total surface area. In that particular place where we have got straight sides, we don't have the curved areas or the curved regions. In that particular place, we'll be dealing with total surface area and not the curved surface area. Now, starting up with 2D shapes, we need to understand the formulas of them. So I'll be just writing them, all of them down step by step, and we'll be going through their formulas as well. For the 2D shapes, we'll be like memorizing or understanding the concept of their areas and the perimeter. So starting up with the first shape, which is a circle. So can any one of you tell me what is the area of circle? What is the formula for area? Yes, anyone of you having any idea what would be the area of this circle? Pi r square, very good. So it's pi r square. Now for the value of pi, if you are dealing with paper 1 and you are specifically a student of O levels and not IGCSE, so you won't be allowed with the calculator. So in that particular case, आपने pi की value को use करना है as 22/7. So pi could have a value of 22/7, or if you're like having calculator with you, then you're going to pick up the value of pi as 3.142. Now, what about the radius? The radius is basically the line coming from the center of the circle until its circumference. So the line from the center of the circle until the circumference is the radius. We have been through the details of the radius and diameter in detail in the previous chapter of circle properties. So the diameter is actually the double of radius. So diameter is actually 2r. Now moving forward, if you see, we have this boundary over here. This ring type thing or this boundary of the circle is actually termed as circumference. So can anyone of you tell me the formula for the circumference? What would be the circumference of this circle? Yes, anyone of you having any idea? How can we figure out the circumference? 2 pi r. Now, one thing you need to understand over here is that whenever you are dealing with any sort of formula of the circle, one thing is common. You are going to deal with pi, like in both of these formulas, you are having pi, and the next thing is radius. तो जब भी आप सर्कल से रिलेटेड या सर्कुलर ऑब्जेक्ट से रिलेटेड कोई भी फॉर्मूला जनरेट करते हैं, whenever you create any formula from any circular shape, you would be dealing with pi and r for sure. So that is something you need to remember. It would help you out throughout this chapter, that whenever we are dealing with a circular body, we are going to deal with pi and r. So now moving forward, if I cut this circle into pieces, like I am trying to make up half of this circle. Now, this is called a semicircle, and this is actually half of the circle. So can anyone of you tell me the area for this half of the circle? It would be the exact same thing as the actual area, but the only difference is going to be that since we are dealing with half of the circle, we'll divide the area by 2. Now, moving forward, if I talk about the circumference is also going to be half of what it usually was. It usually was 2 pi r for an entire circle. If you are taking a half of a circle, you would divide that circumference by 2, and you'll only be left with the value of pi and r. Now, once in 2011, the examiner assessed the students regarding the perimeter of this entire semicircle. So what you were actually asked about was that the examiner was demanding not only the circumference over here, but also this line. Because one thing you need to remember is when we are dealing with perimeter, we are actually dealing with all the touchable boundaries. Like the perimeter is all the touchable sides of any particular shape. Now, if we see over here, we have a half of a circle, and I can touch onto this shape over here and over here. So all of these places where I could touch or where I could like interact with the shape is going to be a part of the perimeter. So for the perimeter, we have got this side as pi r, and the remaining part is actually the diameter, which is 2r. So this is how you could figure out the perimeter, although it is not so important because it was last and only assessed in 2011 May June. So after that it hasn't been assessed so far. So you just need to have an idea of it. It's not like very important thing to remember. Now moving forward onto another type of a circle, like if I divide a circle more and make 4 parts out of it. Can any one of you tell me what is this shape now? इस shape को क्या कहते हैं हम? Anyone having any idea? It's actually a quarter.
यार मुझे ये नहीं समझ था, मेरे ये इतने बड़े हैं, ये पाम मेरा तुम्हारा
Yeah, can any one of you tell me what this shape is called? It is called a quarter. Perfect. Nina, very good. This is a quarter of a circle, and we actually are going to do the same for its area like we did for the half of a circle. So we are going to pick up the area of entire circle and divide it by 4. So that would be the area of this particular quarter. Now talking about the perimeter, what we are going to do is we are going to take up this boundary, which is actually the part of circumference. Now it is 1/4 because it is 1/4. So we are going to take the circumference as 2 pi r divided by 4. Now the perimeter is going to be the entire touchable region. So it is going to be 2 pi r over 4. Now this one is radius and this one is radius as well. So we'll add up both the radii to make up the entire perimeter for this quarter. I'll give you an idea through the shape and you would have a better understanding of the perimeter then. So it was actually a circle like this and we broke a quarter out of it right from here. So this particular part is called a quarter because it's 1/4 of the entire circle. Now if you see, we have the radius over here and this line is also the radius. So we are actually having 2 radii and quarter of the circumference. So that is how we are going to pick up the perimeter. It would be 2 pi r over 4 plus 2 radii, and that would be the perimeter. Now the good thing is, okay, I'll repeat it again. We are having a radius over here and a radius over here as well. And this particular region over here is quarter of the circumference because we are dealing with 1/4 of the circle. So the entire length was called circumference. We are now dealing with 1/4 of it only. So it's called the quarter of the circumference. तो आपके पास circumference actually 2 pi r था, आपने इसको divide by 4 कर देना है to have the circumference for this particular quarter. Now after that, you are going to have the 2 radii with you to add them up and have the total perimeter, and that would be the perimeter for this particular quarter. Now moving forward, the good thing about this quarter shape is that it hasn't been assessed until now and it does not have a good chance to be assessed anywhere soon as well. So now moving to the next shape, which is the rectangle from the list. So any one of you having any idea of the area for rectangle? Yes. What would be the area for a rectangle? Very good. It's length times breadth. Now this particular line over here is your length, and the good thing about rectangle is that it will have the same length over here on the top as well. While if we talk about the sideways, it's the breadth on the right side, and we will have the left side as same as well. And this is going to be the breadth as well. So for the perimeter, the things are pretty easy over here. We just need to add up all of our sides. So we are going to have the length plus the breadth plus the length over here on the top plus the breadth on the side. So it is going to be length plus breadth plus length plus breadth. And to make it easier, we could just make it as 2 times L plus B. Or we could write it as 2L plus 2B. तो आप किसी भी फॉर्मेट पर लिख सकते हैं इस पेरीमीटर के फॉर्मूला को. It's completely your choice. The important thing is that you just need to have the logic of perimeter, that it is the sum of all touchable sides. So if you are having 4 touchable sides on the shape, you are just going to add them up and you will end up getting your perimeter for that particular shape. Now moving forward, we have the next shape in line, and that is triangle. अब triangle में scene ये है that we have already been through the triangles, like a quite detail of it have been taught in trigonometry, and all of those formulas which were taught in trigonometry are applicable over here, and they are going to be very important with mensuration as well, because if the examiner is like assessing you over a pyramid, or he is like assessing you over a complex sort of shape, he could give you a large triangle over there as well. तो वो mensuration के साथ trigonometry को या triangles को definitely connect कर सकते हैं, and he had been doing it a couple of times previously as well. So this was previously assessed in 2015 when he connected a trapezium with a triangle, and that made up the students fall short of like concepts. And he did the same in May-June 2013 as well, where he gave a trapezium, and that was to be solved not only by the logic of trapezium but also by the logic of triangles. So May-June 2013 or 15 में ये assess हो चुका है. So you need to be very good with the concepts of trigonometry if you are going to deal with triangles over here in mensuration. I'm just going to write down 2 core formulas of triangle over here, and the rest of them are on you, and you people need to go through them from trigonometry notes that were provided to you in the group. So we have a 90-degree triangle or a right angle triangle, and we have the 90-degree angle over here, and theta is present right over here. Now, can anyone of you tell me what is this length? What's the name of this length? Anyone having any idea?
Pythagoras theorem.
No, like this length. What's the name of this length?
Hypotenuse.
Hypotenuse. Very good. So that's a hypotenuse. Then what about this one? It's the adjacent or the base. And the last one is right over here on the left side, and that is termed as the perpendicular or opposite. Now, moving forward, you need to have an idea of the area of this triangle. Can anyone of you tell me the formula for area of a right angle triangle? Yes, anyone of you who remembers the area for right angle triangle? Half base into height. Very good, Huda. Now, moving forward, we have the Pythagoras theorem as well. So it's h square is equals to adjacent square plus the opposite square. Now, moving forward onto the next shape, and that is square. So square is basically a regular polygon and it will have all of its sides as equal. So if you people remember from the previous topics, we discussed the concept of regular and irregular polygons. So regular polygon में हमने ये समझा था that whenever we are having a regular polygon, it is going to be a polygon or a geometrical shape with all of its sides and the angles being equal. So the same goes for a square, which is a regular quadrilateral. It is having all of its sides as equal and they are termed as lengths. और आपके पास जो area बनेगा for this shape, it's going to be length times length, or you could write it as L square. So that is your formula for area of this particular shape. Now coming to the perimeter. So the perimeter is with the same logic and it is L plus L plus L plus L, and that would give you 4L as the perimeter. Now moving forward onto the next shape, which is arc. Now all of you need to give a lot of concentration on this क्योंकि ये paper 1 में बहुत ज़्यादा assess होता है. The examiner has like a very fondness of this particular shape over here, which is an arc, and it is like actually a part of the circle. So if we look onto a circle, like if we are looking onto a pizza, we like cut off a part of it or a slice out of it, we will have something looking like this. So this would actually be the shape of the slice of pizza that you would actually cut off. Now from here we start to like generate the formulas by our own selves. अब यहाँ से आगे आपने most of the formulas को खुद generate करना है. So the part for which we were to like memorize the formulas has now been completed, and from here onwards we would be like generating formulas rather than memorizing them. So starting up with this one, we have an arc over here, which is like an actual part of the circle. And if we like cut it off, it will look something like this. Now the entire circle is of 360 degrees, and we are now only dealing with a certain angle out of it. So we will have theta over here as the angle, and we have the total angle of the circle as being 360 degrees. Now, the area of the circle, if any one of you could tell me what was the area of the circle? Yes, what was the area of the circle?
Pi square.
Pi square, very good. So we have the area as pi square. Now, if we are dealing with the arc, we are actually dealing with only the certain angle, the theta, out of the entire angle that was 360 degrees. So हमारे पास angle आ गया है as theta, while the total angle was 360. So we are now dealing with the area as theta over 360 multiplied by pi r square. Now coming to the arc length, which is actually this top part of the arc. So if we are dealing with this part, so you can recall directly that it is the part of the circumference. The thing that we studied previously was called circumference in the circle. Now it is called an arc length. तो अब यहाँ पर हमने नाम चेंज कर दिया है इस लेंथ का और इसको कह रहे हैं arc length. Now arc length could be represented by S or L. So if the examiner is saying that you need to find S for this arc, you are actually being asked about the arc length. Now arc length is the part of the circumference again. So you are going to use the formula of arc length with respect to the circumference. So the circumference was 2 pi r. The angle which I am dealing with over here is theta, while the total angle is 360 degrees. So it's theta over 360 times 2 pi r. And that would be my arc length for this particular shape. Now, moving forward, the examiner could also ask me regarding the perimeter. So this is my arc length. And if you see, this length over here was radius, and this one was also the radius. So the perimeter is going to be 2 radii plus the arc length. Over here, if you see, we have the arc length over here. We have the radius on the side and the radius on the left side as well. So it is going to be theta over 360 with 2 pi r for the arc length, and then added up with 2 radii. So that would give you the entire perimeter for this particular arc. Now moving forward, we have some other forms of arc as well, and the examiner could actually tell you that the arc is a sector. तो examiner कुछ और terms भी use कर सकता है arc के लिए, and that is a sector. Now the sector could have two types. It could have a minor sector or a major sector. So talking about the sector, we have, let's say, a circle over here, and I'm making up an arc like this. So if I'm dealing with the smaller part over here, if I'm dealing with the smaller part, now this is called the minor arc or minor sector. So it could be termed as arc, it could be termed as sector, and also it could be termed as a segment. So the terms of arc, the term of sector and segment all have the same meaning. Now, if the examiner is saying that you need to figure out the area of minor arc or minor sector, you are actually going to figure out the area for this particular part. In case, if the examiner tells you to figure out the area for the major arc or major segment, then you are going to deal with this remaining part right over here. Now that is something very important. You need to take care of it and remember the logic of it. Now what we are going to do here is we are just going to use the exact same logic, the exact same formula, but the only difference is going to be of angle. Like if I am having an angle of 50 degrees over here, and I am trying to find the area of minor arc, then the area of the circle is pi r square. I'm going to multiply it with theta divided by 360. The radius has been provided, let's say, as 10 centimeter. So I'm just going to pick up the values, put them into the formula and find my answer. So for that particular thing, I'll pick up the angle as 50 divided by 360 times pi, which is 3.14, times the radius, which is 10. So that would actually give you the area for the minor arc. And let's say it's turning out to be 210. Now let's suppose this is your area for the minor arc. In case if the examiner asks you about the area for major arc, तो अब हमने क्या करना है ये आप जरा समझ लें. What I am going to do here now is that I am going to take up the angle for this particular region. The larger angle would be figured out. So I'll find out the larger angle right from here. And that is going to be figured out by 360 minus the top angle, which is 50 degrees. So the entire circle is of 360 degrees. The top part is 50 degrees already provided. I'll just subtract them and I'll have the bottom angle, and that is 310 degrees. I did 360 subtracted with the angle of minor arc. So it would be 310, and that would be my theta for the major arc. Now doing the exact same thing, theta over 360 multiplied by pi multiplied by the radius, which is 10. And you'll end up getting your answer for this particular part as, let's suppose, 1300 centimeter square. Now, if we talk about the area, or we talk about the circumference, or about the perimeter, you just need to remember one thing. If we are dealing with the minor arc, I'll pick up the angle of the smaller portion. If I'm dealing with the minor arc, I'll pick up the angle of a smaller portion. And if I'm dealing with the major arc, I'll pick up the angle of the greater region right over here. So the major arc is the one having greater angle, while the minor arc is the one having a smaller angle. That's the logic. Now the formula and the radius is going to be exactly same. So you just need to make a difference with the angle and you'll get your answer either for the minor or the major arc. I hope this is perfectly clear. So now before moving on to the next shape, I want a confirmation from you people if all of you are perfectly clear with the thing taught over here, or is it like ambiguous? Kisi ko koi problem, or like all of you are perfectly clear? Okay, perfect.
Yes.
Now moving forward, okay, Mina, basically 3.14 is the value of pi. The same goes over here. 3.14 is the value of pi and the radius was 10. You can also keep the value of pi as 3.142. So that's also acceptable. Now moving forward, we have the next shape, which is a trapezium. So talking about the trapezium, it's basically a combination of a triangle with a rectangle. It would have a rectangle like this, and we'll have a triangle over its top, and they would be like joined together like this. So this is going to be a trapezium. It could be like vertically placed and it could be horizontally placed as well. So you could see the trapezium in these two orientations, and there is another form in which the trapezium could be placed, and that is actually a completely different shape. It could be placed like this. So all of these shapes are falling under the category of trapezium, and you need to have the same formula for each one of them. Now let's talk about their area and their perimeter. So first of all, we need to understand their lengths. The two lines that you see are moving parallel are actually termed as A and B. तो वो दो lines जो कि parallel जा रही हैं right over here, उनका नाम हमने रखा है A and B. So we have A and B over here. Now the height in between these two lines, like the vertical or the horizontal line between these two parallel lines, is actually going to be your H right over here. This is your H. Now in case if you don't see a vertical line in between these two parallel lines, like in the third shape, we don't have any vertical or horizontal line. So we are going to make it by our own self. We can make it over here, we can make it over here, or in the center. That's completely your choice. Now I've made up the height at the right corner. So this would be my edge right over here. Now comes up the formula. So the formula for its area is going to be half times sum of parallel sides times the height, and that would be the area for trapezium. Now, in case if you're not comfortable with the formula, you can use the logic of rectangle and the triangle. Like I am having a rectangle over here, and over its top, I am having a triangle. Now, what I am going to do is I'm going to pick up the area for this triangle as half times base times height, and the area for this rectangle as length multiplied by breadth. I'll just pick them up and I'll figure out the total area of this trapezium indirectly rather than using this particular formula. So both of these logics are completely acceptable, but the problem is that usually the examiner would not directly assess you on trapezium. He would indirectly connect the triangle with the rectangle. Like the examiner would bring up a shape looking something like this and would tell you that the area for this triangle is 20 while the height has been provided as 8 centimeter, and you need to find the breadth over here. So आपने breadth find करना है for the rectangle. What you are going to do over here is that you are going to use the area of triangle to figure out the base. The base of this triangle would be figured out first. So what we will do is we will pick up area is equals to 1/2 multiplied by base multiplied by height. So the base has been given as unknown while the height has been given as 8 and the area is 20. So I'm going to manipulate the values and figure out the value of x for myself. That is actually going to give 40 divided by 8 is equals to x, and x would finally turn out as 5 centimeter. Now the good thing about this shape is that if you're having this length as 5, this one is going to be 5 as well. So the breadth or the base are going to be exactly same. The base of triangle and the breadth of your rectangle are going to be exactly same and identical. So it is turning out to be 5 centimeter, whether be it the base of triangle, the upward line right over here, or the bottom one, which is the breadth of the rectangle, that would also be 5 centimeter. I hope this is perfectly clear. Now we are done with all the 2-dimensional shapes, and now we are moving on to the 3-dimensional shapes. But before moving on to them, I need a confirmation from you people if 2-dimensional shapes are like perfectly clear, या किसी को कोई problem और कोई query है तो पूछ लें. Anyone of you having any sort of query in 2-dimensional shapes? Okay, perfect. So now we are starting with 3D shapes, and in the 3D shapes we need to focus on cylinder first of all. So we'll be discussing the cylinder. It looks something like this, and we have the center over here for this circle. We have the circle at the top and we have an identical circle at the bottom as well. We have the center of the circle and we have the radius over here. And this line over here is actually representing the height. Now, what we understand over here is that we have a shape which is having a circle at the top and a circle at the bottom. The circle at the top and bottom are identical and they are combined or joined by straight lines on either sides. Now we have the radius for each of these circles and we have the height for this entire shape. अब यहाँ पर एक चीज हमें समझनी है that if we are dealing with any 3D shape, the volume is going to be the area multiplied by the measured out length. Area multiplied by measured out length. Now you need to learn this thing and use it in every single case that is going to come forward towards you. So volume is always going to be the area of one face multiplied by the measured out length from that particular shape. Let's take up an example of this cylinder. So if we are dealing with a cylinder, we are having a circle at the top. So can any one of you tell me what would be the area of this circle at the top? What would be the formula for the area? Any one of you?
Pi r square.
Pi r square, very good. So it is going to be pi r square for the area of the top face. Now the length which has been measured out from the area but was present in the shape, the length that has been measured out in the area but was present in the shape, it is height. Height is the length जो कि shape में मौजूद है लेकिन हमने यहाँ पर area की जगह पे use नहीं किया है. So we are going to pick up that length, which is height in this case, and multiply it over here, and that is going to be the volume for the cylinder. It is pi r square times h, and that would give you the perfect answer each and every single time when you are dealing with a cylinder. I hope this is perfectly clear. If you're having any sort of query, just let me know and I'll explain it again. So any one of you having any sort of query, I'll just explain it again if any one of you is having any ambiguity on this. किसी को कोई problem, कोई query इसमें? Okay, perfect. So now we are moving forward on to the next concept, and that is the curved surface area. Now, if you remember, when we started with circle, I told you one thing, that if we are dealing with any shape having circle or curved area in it, we would be dealing with pi r. We would always be dealing with pi and r. तो कोई भी curved shape होगा जिसमें circle नजर आ रहा है या उसमें curve मौजूद है, तो उस shape के लिए आपने pi r लाजमी use करना होता है. So we are going to use pi r for sure in this shape as well. So for the curved surface area, it is going to be pi r for sure. Now we need to understand what is the curved region. Curved region is this one over here. Excluding the top and the bottom circle, we have this area as a curved region. So the entire region of the cylinder except the top and the bottom is going to be your curved area. And this curved area is having a height of h centimeters, and we are having two circles at the top and bottom, so we'll just combine them over here, and that would become the curved surface area as 2 pi r times height, and that would be your curved surface area for cylinder. I'll repeat it again. The curved area is this shaded area over here, excluding the top and bottom circles, and it is expanded on a length of h centimeter. So since we are dealing with curved area, we would have pi r, then we have the height as h, and we have a circle at the top and bottom, which are two circles in total. So we would make it 2 pi r times height, and that would be curved surface area. Now moving forward, we have the next formula, in fact the last formula for this shape, and that is your total surface area. So the total surface area for the cylinder is actually going to be your top circle, your curved region right over here, and then your bottom circle over here. So it is going to be a circle at the top, which is pi r square, plus the curved surface area, which is 2 pi r h. We just figured it out over here. And then we have an area at the bottom as well, which is pi r square again. So we can just combine these two areas together and make them as 2 pi r square plus 2 pi r h. Although you can just leave it over here as well. And I would personally suggest you to leave it until there and not use this particular simplified format, because the simplified format would cause you problems ahead as well. Now, we are done with the curved surface area. We are done with the total surface area as well. Now let's take up an example of a past exam question. So in 2017, there was a shape having a cylinder, but on the top of this cylinder, we were provided with a cone. So the examiner actually gave us a cone at the top. Now this is your cylinder, and we are now having a cone at the top as well. The examiner asked us about the curved surface area and then the total surface area for this cylinder. Now you need to remember one thing. Curved surface area is just like your perimeter. Curved surface area is just like your perimeter. So if you are dealing with the surface area, it would be the touchable region. Total surface area is just like the perimeter and would be the total touchable region. So wherever I could touch the shape would come into the total surface area. And now over here, we are having the top face covered with the cone. So what we are going to do over here is, we are going to consider this curved region and this bottom circle only as the touchable region. क्योंकि मैं इस सिलेंडर पे सिर्फ साइड्स पर जो कि कर्व्ड रीजन है वहां पे और बॉटम पे टच कर सकता हूं, तो मैंने सिर्फ कर्व्ड रीजन और बॉटम रीजन को ही टोटल सरफेस एरिया में फॉल करवाना है, and that is going to give me 2 pi r h plus the bottom circle, which is pi r square, and that is going to be my total surface area in this particular case. So this was a question from 2017, and most of the students made a mistake in this particular formula and they found a wrong value. They were actually using 2 pi r square instead of a bottom pi r square only. We were not going to consider the top circle in this case because it is covered and we cannot touch it. So we would not consider it to be a part of total surface area anymore. So we are going to consider the curved surface area and the bottom circle area only. And that would lend you at 2 pi r h for the curved surface area and pi r square for the bottom circle. That would be your final answer for this particular query. Now we are done with the cylinder concepts, and in the next class we are going to start further and move further towards the next 3D shapes. And for now, we are going to keep it till here for today. If any one of you is having any sort of query with anything which has been taught today, just let me know and I'll explain it again. So any one of you having any sort of query from today's lecture?
Sir, this cone and cylinder figure, I didn't understand the total surface area.
Okay. So what you have got over here is that you had a cylinder and you placed a cone over its top. Now, if you see, we have this circle from the cylinder being covered by the cone. अब ये cone से cover हो चुका है and we cannot touch it anymore. So since we cannot touch it, we would not consider a part of total surface area. So the total surface area would actually be this curved region from the cylinder, which I can like still touch and be in contact with, and I can also consider this bottom circle as my touchable region. So I would actually be picking up the curved surface area, which is 2 pi r, and I'm going to pick up this bottom circle, which is pi r square, and I'm going to add them together to figure out total surface area. तो टोटल सरफेस एरिया के लिए आपने कर्व्ड रीजन को लेना है और बॉटम सर्कल को लेना है, एंड यू वुड नॉट बी कंसीडरिंग द टॉप सर्कल इन दिस केस because you cannot touch it anymore. It has been covered by the cone. So that is why we are ignoring the top circle from our shape in total surface area in this case. Are you clear now? Okay, perfect. So we would be keeping it till here. Hope everyone is perfectly clear with everything taught today. In the next class, we are going to cover up the later shapes from the 3D shapes. And then we are going to start with past paper questions as well. So that's a wrap for today. Take care, everyone. Allah Hafiz.